Because it's hard. Yes. Okay. Okay. Shh. After break. Okay, listen carefully. After break, we are going to do section 7-1 through 7-5 on Monday through Friday of that week. Maybe Monday through, well, I don't know. Don't know what's happening Friday. I may have to be gone for the day, but we'll see. Both parts in your chest because it's hard. I'm sorry, what? Whenever you need to use a calculator. I don't remember. Bring one anyway. Okay. Then after that, we will test on chapter 7 and we will review. Okay, guys? Nick? Back? Type 2. Okay, you guys? Know what the plans are. If you're going to be gone after break, you're going to start with chapter 7, section 7-1, which is, no. This is the hardest stuff right now. Well, that is. But right now, this is the hardest stuff. Now, you guys, on your test, some will be without a calculator, some will be with. Okay, guys? You need area. You have some multiple choice questions that I gave you. You have volume. You have arc length. Do you remember how to find arc length? And then you have the vectors. And then you have the polars. Now remember on the vectors, I think some of it's multiple choice. Do some free response. Pardon? All of this. Area and volume is the review. All the rest is new. Well, vectors aren't. But, this is your x coordinate and your y coordinate. Then to find your velocity in the x direction. Shh, you guys, I need quiet. It's dx dt. The velocity in the y direction is dy dt. So the acceleration in the x direction is the second derivative. That's it. That's the vector for the acceleration. Acceleration in the y direction. Well, that's what I'm not done. No, I'm not done. How do you find your speed? Okay, girls. The speed, no, is equal to the square root of v sub x squared plus v sub y squared. So how do you find arc length? That's the velocity times the time. So guess what we do? We integrate from t1 to t2 the square root of v sub x squared plus v sub y squared. Now, there are two other forms for arc length. Question. That's the speed. Plus dx dt squared plus dy dt squared. Doesn't get any easier. Okay? Then you have other forms. You have this one, which is the square root of 1 plus dy dx squared dx from x1 to x2, or you have this one, and it's y1 to y2 square root of 1 plus dx dy. It depends on what you're given. If I'm given my functions with y's in it, x in terms of y, I'll use the third one. If I'm given functions with y's and x's, and it's y in terms of x, I'll use the second one. If I'm given to me parametrically, I'll do the first one. And I know that in 2012, I think it was number 3, they had you use the second one. Sam. I memorized them. That was section 6.4. Yes. How I get the speed is I find the velocity in the x direction, find the velocity in the y direction, and it's the resultant vector, Pythagorean theorem. Okay, shh. That's L. This is the length of a curve. So the diving problem, the girl on the diving board, that's arc length. It's asked how much distance should she go in the air. So it's this, all of this distance of that arc. Now, once I know what the speed is, which is the absolute value of the velocity, then if I take that, and it is an absolute value already, and if I integrate my velocity, rate times time gives me position. So that gives me the length of my arc. L is equal to the integral of v of t dt. That's what that says. Yeah. John. Matt. Okay. We're going to get to polars in a second. Questions over there? We're not done with vectors, though. Wait. What? Oh, that's okay. I'm not done with it. Okay, girls, there's a little bit more with the vectors. The equation of the tangent line is, equation of any line is y minus y1 equals dy dx, the derivative, x minus x1. That's m. How do you find dy dx if you're given parametrics? Dy dt over dx dt. Parametrics aren't too bad, really. Why? BC is quite a bit harder than AB. It just is. I think I've got everything for the vectors. We're going to do that. Yeah. Marissa, this dy dx is dy dt over dx dt. That's what it is. If you did the algebra on here, it simplified this complex fraction, you'll get dy dx. Equation of a line. The slope of the tangent line. Okay, those of you who are talking, please don't. Let's do the last one, the polars. There's a lot of stuff for the polars. Okay, first thing is you're going to take this is r, this is x, this is y. So x equals what? R cosine theta. You have to know that. R sine theta. X squared plus, this is all you need to know, equals R squared. Okay, shh. Guys, I just asked you a couple minutes ago, Nick, tangent of theta is equal to what? Y over x. Now remember that when you take the derivative, if I do dx d theta, I must do r times the sine of theta, negative sine of theta, plus the cosine of theta times dr d theta. You have to use the product rule. R changes in time. Similarly for dy d theta. If you want me to write it out, I can, but just use the product rule. Okay? And I'm going to change colors because it's going to get messed up here. Dy d theta is equal to r times the derivative of the sine, which is cosine of theta, here, plus the sine of theta times dr d theta. I'm sorry, what? Nope, the derivative of the sine is positive. Derivative of the co is negative. Remember, all the derivatives of the cofunctions are negative. This came from the derivative of the sine. So it's positive. Hey, Eric. Yes. It's a lot easier if you pay attention and you do the practice problems. It's just so much easier. I make it easy for you if you listen. Or noise. Okay, I think I've got everything. Do you remember how you graph it? It's r theta. That's going to be important. So let's do the first problem I gave you, 2009, number 4. No calculator. 2009, number 4. No? Okay. Yeah, I just memorized it. You guys, guess what? Oh, no, 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 probably more than that. But you guys, this is pre-calc. That's pre-calc. You know that. No, it's not. Cosine of theta is x over r. We've done that in pre-calc. It's the unit circle. No, there's nothing here except for the derivatives. So let's do this one, because it's not an easy one. You have that. This is on the very first the sheet I gave you today. And it's, first off, it's intimidating. Okay, Bjorn? But it's not that bad. Does everybody have a copy? Okay, so David, you probably should be turned around. I'm given a polar curve, r equals 1 minus 2 cosine of theta. It's the angles that cause me the trouble. And theta is between 0 and pi. Okay, you guys, let's see where this graph starts. You don't have a graphing calculator. So if theta is equal to 0, then r is equal to 1 minus 2 times the cosine of 0. So r is equal to 1 minus 2, right? Cosine of 0 is 1. So that's negative 1. Okay, remember how to graph these. You start at the origin, and my angle is 0 degrees. So I'm not going to rotate. And I would go 1 to the right and be here, but because that's negative, I'm going to go 1 to the left. There it is. Theta equals 0. Weird, isn't it weird? Let's let theta be pi, because it doesn't hurt for us to review that. So if theta is equal to pi, then I haven't even started it. I'm just graphing points here to see what's going on. So if theta is equal to pi, then I get 1 minus 2 cosine of pi. What's the cosine of pi? That is 2, that's negative 1. So r is equal to 1 plus 2, or 3. Okay, I'm going to use a different color. So theta is equal to pi, so I'm going to go this way. And I'm going to go 3 units to the left, because it's a positive 3. So theta is equal to pi there. Wait, can't do it with the talking. Okay, guys, if you're going to talk, the door's there, so I don't have to go talk over you. Okay, Zach? But because theta is pi, remember it's r theta, so I'm going to take my ray and rotate it 180 degrees, and my radius is positive. So I want 3 units on that ray. Yes, but we're negative, always starting at 0. If they had given me negative 3, 0, then I would have gone no units to no rotation, but I would have gotten 3 units to the left. Same thing. But they gave me that theta is between 0 and pi. Well, what do you think another theta would be nice to try? I did 0. Pi over 2. Sounds like a good one. Okay, Eric? I want pi over 2. Pi over 3 sounds too hard. Okay, you guys will get there. So r equals 1 minus the 2 times the cosine of pi over 2. What's the cosine of pi over 2? What's the cosine of 90? There's 2 pi, there's pi over 2. 0. So this r is equal to 1. So if I go 90 degrees, so I'm going to rotate 90 degrees, and I'm going to go 1 unit up. There it is. That's that point. Darn it, I want the shaded region. So what angle is that? Okay, because what do I want? What do I want r to be right here? So 0 equals 1 minus 2 cosine theta. So 2 cosine theta is equal to 1, and the cosine of my angle is 1/2. So I'm going to draw a triangle, because I can never remember. This is 1, this is 2, this is square root of 3. Okay, guys? This is 30 degrees, this is 60 degrees, so it's pi over 3. Okay, so part A, write the integral expression for the area of f. So we are going to integrate. Remember what the formula is? I forgot that formula on my sheet. Better go back and put it there. Area, I forgot the area formula. Yes, area of a polar curve is 1/2 r squared d theta, from theta 1 to theta 2. If you want me to prove it to you again, I will. It's in one of the previous videos. Because area is equal to theta over how many radians in a circle? 2 pi. So it's how many radians we have out of 2 pi times pi r squared. What happens to the pi's? There's the 1/2. That's d theta. Okay. But it says write an integral expression. Do I have to integrate it? No. So it's the integral. It's 1/2. Let's see, r was what? 1 minus 2 cosine theta? And you get a point for knowing that. And where are my thetas going between? 0 and pi over 3. Because that's r. It is clearly defined in the problem, but the thing is I'm not sure that you knew it was at r. So I think the answer to that question is yes, you probably get it wrong. Shall we see how many points we got? Yes. Guys, if you're talking, I can't hear. Yes. Because I want this shaded region. So I'm going to start here at 0 and go to that. So that's when r is equal to 0. And I solve this trig equation. Without a calculator, cosine's 1/2. To 30, 60, 90. Okay, guys. What? I'm not going to do an inverse. Pretty quick. The cosine of some angle is 1 over 2. I know that's square root of 3. I know the 30, 60, 90 triangle. So you have to have that memorized. Well, don't you want to know how many points you got? 2. You get 1 point for this. So if you got that, you got a point. Matt? And you got 1 point for that. R? It's 1/2 r squared d theta. From theta 1 to theta 2. Good thing I'm doing this. I think you'll be dying tomorrow. Might be dying anyway. Hope not. And the way to assure that is to not practice. If you practice, you'll be fine, because you know what? You know you're going to get an AP problem. How many of them are there? Not very many. So if you do them all, and we're doing some today in class, we'll do at least 2, maybe more. Now, how do you find, Eric, how do you find dx d theta? Yeah. I prefer to put the r in right now. Guys, if you want to talk, please leave. I'm serious. So x is equal to 1 minus 2 cosine theta times the cosine of theta. Does everybody see that? That came from the triangles. We did, and I derived it again today. Remember? You guys, that's what you have to know. This is all you have to know for the new stuff. Guys, I can't hear. Yeah, I haven't done d theta yet. I'm going to do that. By the way, guys, you get your point for that. So that's easy. Now, you could multiply it out, or you could just use the product rule. I'm just going to use the product rule. Because guess what? It's product rule and the chain rule, and it doesn't say you have to do anything with it. It just says find it. So what's dx d theta? Well, it's the first one times the derivative of the second one, which is negative sine theta, plus cosine of theta times the derivative of the first one. So it's negative, well, it's not negative, it's positive 2 sine theta. And it's d theta d theta. That's all you have to do. That was pretty easy. If you know what I just told you about the basic things, what you have to know, I think you'll be fine. Actually, I almost like them better than the vectors. Okay, we have to find dy d theta. What's y equal to? R sine times sine theta. Because what's the derivative of cosine? Negative. So the negatives will cancel. So what's dy d theta? It's r times, well, wait. What's r? I gotta put that in. 1 minus 2 cosine theta. You know, it's probably one reason why they don't do tuning with the polars. It's probably hard for them to find nice functions. Whoops, that's not dy d theta. Yeah. There. So, how do you find dy d theta? It's 1 minus 2 cosine theta times the derivative of the sine. Positive or negative? Positive. Cosine of theta plus the sine of theta times the derivative of this parentheses, which is, we just did, it's positive 2 because the derivative of cosine is negative. Okay. No, because you can't have it on your exam. It's not that hard. There's not that much stuff there. This you should know from pre-calc. That's Pythagorean's theorem. That's just the definition of tangent. The only thing that's new is that. 1/2 r squared d theta. That's all it is. And I proved it by doing this. Okay. Now, do you want to know how many points we got? I do. 4. 4 points. Okay, you guys? Look, you got a point for just doing this. Now, they said dr d theta. The fact that you did that, it'll be just elsewhere in the problem. Remember the derivative of 1 minus 2 cosine theta was 2 sine theta? That's what this is. So you get 1 point for that, and then you get 2 points for getting your answers right. It's okay. They simplified it. You don't have to. This is full points. We don't have to simplify those. Okay, guess what? This is dr d theta. So you have it here, and you have it there. So you get 1 point for that, and then 1 point for all the rest of it being right. So what have we got? 6? Was this hard? It looks hard. When I look at that picture, I say it's hard because I'm not familiar with it. I'm not familiar with it. Okay, write an equation in terms of x and y for the tangent line to the polar curve at theta equals pi over 2. Oh, how do you find dy dx? Dy dx is equal to dy d theta divided by dx d theta. And guess what? We're going to do this at pi over 2. Now, before we go on, what's the sign of pi over 2? Because that's what I'm going to have to do. Okay? Trevor, what is that? Nick, what is that? That's 1. If you don't know, draw the sine curve. What's the cosine of pi over 2? The sine of pi over 2 is 1, then the cosine of pi over 2 is 0. Okay, I don't want to rewrite all this. Let's just go and substitute it in. I have to have a dx d theta and dy d theta. Oh, let's do this in green. Cosine of pi over 2 is how much? 0. So this is 1. What's the sine of pi over 2? 1. So that's times negative 1, right? Plus, and let's see, the cosine of pi over 2 is 0 times that. So the answer, dx d theta, is going to be equal to negative 1. Yeah, you can. I'm just doing it now, saving time and space. Andrew. Let's see. No, because this is 0. That's 0. So it's 1 times that. Good question. Really good question. Yep, I'm going to find them. I mean, I could write it all out. I didn't want to do it. At theta equals pi over 2, then this is going to be 1 minus 0, right? Yep. Times 0 plus the sine of 90 degrees is 1 times 2 times the sine of 90 degrees. Oh, that's 2. Okay, so what's dy dx? It's dy d theta, because that's what you want to do. You don't want to take time. It's 2 over what? Negative 1? Which is negative 2. Ask. Because dy d theta is 2. Because negative 1. Did you get 2 for this one? Let's figure out where your mistake is. No. This is 0. So it's 1 minus 0. Okay? And then I want the equation of the tangent line, which is y minus y1 equals my slope, negative 2x minus x1. But I know what x and y are if I'm smart. R equals 1 minus the cosine of, sorry, that's not right. R equals 1 minus 2 cosine of theta. At theta equals 90 degrees, or pi over 2, how big is the radius? It's 1 minus 2 times the cosine of 90. That's just 1. We're doing the equation of the tangent line now. It asked me for that, right? Find the equation of the tangent line at theta equals pi over 2. Because it says theta is pi over 2. So now I know that. So what is x? X equals r cosine theta. What's r equal to? I just figured it out. Is 1 times the cosine of pi over 2, which is 0. Y equals r times the sine of theta. R is equal to 1, and the sine of pi over 2 is what? 1. Hope I did it right, but I think I did. So it's y minus the y value, which is 1, equals, guys, negative 2x minus 0. Done. Now, that'd be 3 points. 1 point probably for the slope, maybe 2 for the slope. I don't know. Let's see. Okay, finding the values of x and y, that was worth a point. Finding the slope was a point. Writing the equation with a tangent line was a point. How they would grade it if you messed up one of those, I don't know. My guess is you're not eligible for the answer point there if you messed up one of those. That's my guess. It depends on the question leader. It's 2 over 1. It's change in y over the change in x. See y d theta over dx d theta. Do you have it upside down? Yep. But you know what? If that were the case, let's say you did dy d theta, dy dx upside down, but everything else is right, I'm sure you get 2 points out of 3. It's just if you're way off that you wouldn't get much. But it was only 6 points. Really? Now, was it that hard to do? No, but they are scary looking when you first see them. Should we do the next one? I don't even know what the next one is. Ooh, is that 2007? Oh, let's do 2003. I have it here someplace. And then 2007, if we have a chance. Do you have two? Yeah, you have 2007. It's a regular problem. 2003, is that a B? I got to try and find it. That's not the 2003 I want. Yeah. I'll see if I've got it in my pack. If I don't have it in my pack, I'll have to find it. Is this one? Let me look at it. Oh, yeah. This one's tricky. Now, after break, I will come back and review polars at night because they're tricky. So let's, you know what's nice about the IB exam is they give you time to read the exam before they start you on the exam. Well, it really would be nice if we could do that because this looks just horrendous, but there is a little trick on this one. It says the graphs of the polar curves r equals 2. Which one's r equals 2? This is 2007. So it's been since 2007, okay, guys, since we've had a polar. Yes, it is. Oh, no, that's 2003. Oh, we'll do the one on the back. If I have to go and make it up, I will. Oh, that's another fun one. Okay, in 2003, oh, this was Form B. 2003, they had this one on the regular and had this one on the BC. Oh, there it is. Now I'll save this so you have it as a PDF. It's in the smart boards, okay? So if you don't have a copy of the questions, you still can do them. You should, though, have a copy of them. Okay, we have x squared plus y squared equals 2. Or they could have said r equals the square root of 2. So that's this one. X squared plus y squared equals 2. This one is just moving the circle over. So it's x minus 1 squared plus y squared equals 1. They even tell you where the graphs intersect. Okay? Let R be the shaded region in the first quadrant bounded by the two circles and the x-axis. We want to find the area of R in A with respect to x. B, set up an expression involving one or more integrals with respect to y. That's the area of R. Okay, that's chapter 6. That's not polars. Yes, it is. The radius is square root of 2, 1.414. This is probably a double bubble problem. This is AB to do A and B. C is the polar equations. These are not polar curves. So they want you to find the area with respect to x of region R. So that means I'm going to draw a slice like this. This is not 1/2 R squared. This is regular good old area. And then you're going to have to do this one. why it helps to read the question first. So A, now, do a vertical slice, what are you going to do? Do you remember? It says, with respect to x, this is not a polar curve. They did give us polars right over here. That's not till C. They tricked you. This is worth, I'm going to guess this is worth 4 and this is worth 5. I think this is a double bubble one. In other words, half of it's AB and the other half is BC, but half is 60%. Okay, so how do you find this area? It's this y value minus 0, call that y1, times the differential dx from 0 to where they intersect, plus, and then we have to do this one. Oh, let me do it in red, which is this circle. Call that y2. So it's plus the integral of y2 minus 0 with respect to x. Just so you see that. It's just the length of this. This is y equal to 0. I am subtracting. I'm finding the area of this region right here, and then I'm going to find the area of this little region right there and add them together because it's two different functions. You must have two different integrals. So guess what I have to do? I have to solve these equations for y. Which part of y are they going to be? X squared plus y squared equals 2, then y squared is equal to 2 minus x squared, and then what do I do? Square root. Absolute value of y is equal to the square root of 2 minus x squared. So y is equal to the positive 1 or the negative 1. Why am I going to throw out the negative? Because it's the top half of the circle. Same thing here. Y squared equals 1 minus x minus 1 squared. Square root. Absolute value of y is equal to the square root of 1 minus x minus 1 squared. So I'm going to take which one, the positive root or the negative? Positive. And they didn't ask you to integrate it. So that's what that looks like. So the first one is the first function, which is right up there, square root of 2 minus x squared. We'll get the values here in a second. Square root of 2 minus, that's always the hard part anyway. Dx plus, and this one's going to be the other one. Now you could label it y1 and y2 as long as it's clearly labeled to the reader. Square root of 1 minus, honestly, I probably, if I have the time, would write it down just to be sure. Now where are we going to integrate? Where do the x's start here in the yellow region? 0, and they go to where? 1, because they told me that. Right there. So this is 0 to 1, and then 1 to this point. Where is that? Square root of 2, isn't it? What's wrong? That's the square root of 2. Because r squared equals 2. So r equals the square root of 2. Well, r can only be positive. Okay, let's look at the answers. I like to do that. Or, we did it with all the calculus because I wasn't thinking very well. I just plain did it. 3 points. 1 point for the integrand of the larger circle. Which is the larger circle? Well, it doesn't matter. 1 point for this, 1 point for that, and 1 point for both of your limits being correct. Now, what else they do is they use geometry. Let's see, where is it? It's this piece right there. Look at that. That's a quarter of a circle, isn't it? I even had it outlined. You'd think I would have seen that. You see that? You could use geometry to find that yellow section. So it doesn't matter. They're both right. So we got 3 points for that. Guess what we get to do for B? Let's slice this the other way. I'm out of colors. We want to slice it. I don't want that color. Well, I'll use this. This way. So guess what? It's this x coordinate minus that x coordinate. Guess what you have to do? Solve for x in terms of y. But it's only one integral. It's the integral x1 minus x2 dy, and the y's go from 0 to where? I think it's still 1, isn't it? Yes, it is. So now I have to solve x squared plus y squared is equal to 2. So x squared is equal to 2 minus y squared. So x is equal to the square root of this. We're going to take the positive one because it's to the right. I just have to get it in the right order. Now, let's see, the other one was x minus 1 squared plus y squared equals, was it 2? 2? Is it? Thank you. I wasn't sure. Okay, so x minus 1 squared equals 1 minus y squared, and then you square root. And I do get the absolute value of that. I probably shouldn't be so lax on that. Well, you know what? I got to be careful. Which one is that? Is that the negative or is that the positive? The positive equals the square root of this. So x is equal to 1 plus this. Or x minus 1 equals the negative of that. Which one works? Okay, so if you're this is going to be the positive one, but what about this one? I think it's going to be the negative, isn't it? Am I right? So I'm looking at, oh, that's a positive one. And then this one. Oh, I want, this one is bigger. So I want this one, which was centered at the origin. That one goes first. So this one. That one is larger. The problem is, I got to figure out which one I want here. What do you think? If y is equal to 0, if y equals 0, x equals 1 plus 1, which is 2. If I try y equal to 0 here, x equals 1 minus 1, which is 0. So when y equals 0, x is equal to 2. Do I want this one or do I want that one? This is of this circle. When x equals, sorry, when y equals 0, x is equal to 2. I don't want this piece. I want this one, don't I? Yeah. So I want this one, which happens to be that one. Yeah. Because it's the absolute value here. And there are two things I can put in here. The positive, or I could put in the negative. They're both true. Because you've got half of a circle. You've got to figure out which half you have. Yeah, I got to get the right one. I want this one. I do want that. Because which curve do I want? No, these are horizontal now. They're not functions. I want this curve or I want that one. No, I want this one because my region's in here. I'm making a mess out of it now. Well, let's check. So it's the first one. It's this one. This is AB Calc. I don't remember what's on the test. Minus this one. dy, and the y's went from 0 to 1. Shall we check? Did I do it right? I sure did. Okay, 1 point for your limits, 1 point for the integrand. Now, If you put a plus here, you're going to get 2 out of 3. That's all. 1 penalty point. No, I did 0 to 1 and 1 to square root 2. This is 0 to 1. This one right here? This one? I don't think so. Do I? It's right there. Oh, these I have mixed up. That's supposed to be 0 to 1. Was I not careful? Order is not important. No. I lose a point. Dang it. Yeah, that's what I'm trying to figure out. Yep. This should have been 0 to, this should be 1 to square root 2. Yes. Then this should be 0 to 1. Because it doesn't matter. It's plus. Look at that. I got the hard stuff. How much did I get for the hard stuff? 3. So I'm at 5 out of 6. Not, part B, we got 6. So you get 3 left. Okay, let's do the polar curve. That's the easy part, actually. Oh, do the polar curve. Now, I'll save this. I will save this. I'll export it up as a PDF. Then you have all those other problems you can play with. But no, it's not time yet. No, it's not. You're not going to believe what I just read on the news. Well, I didn't have my phone out, so, because I'm not supposed to, like you're not supposed to. Tubby Smith got fired. He got them to the NCAA. Oh. Okay, it's 1/2 r squared d theta. Oh, that one looks tough. I don't think it's going to be simple. Mm-mm. Okay, you guys, how are we going to do the last piece? And I got a mess on my picture here. No, it's not. What are you going to do if it's on this is on the test tomorrow? Cry. No, you won't. Okay, you guys, so I just wanted, I got to go from here to there. Am I just doing what region? I didn't look. Okay, excuse me. R is only the top part. So I have to go from here to here. What? I have to go from here to here. That's 0. Where's that? So you're going to find this one, this pi, and then what else you have to do? I don't want all that, do I? So I'm going to find this one from here, and then this one I'm going to do, let's see. I don't know, I got to think about that. How are you going to do that? Eric, how am I going to do that? Well, I can still do the quarter circle. That's okay. Let me see how they do that. Yeah, there's the circle. And pi over 4 to pi over 2. Wait, which one is that? Oh, over 2 cosine theta. I got to think about that. That's not easy. So there you go. Bring your questions tomorrow morning. But everybody's taking a test tomorrow. That's the problem.